Good morning, student. Myself MD Moinuddin, and in my previous class, I have discussed about quadratic equation. So this is the main topic is relations between roots and its coefficient, okay, and nature of roots and transformations of roots, okay, transformations of equations. So we have understand at first what is the nature of this chapter. So one by one, I will write who are the points of the nature of the chapter. So first is relations between roots and its coefficient, and nature of roots, transformations of equations. Okay, and fourth is locations of roots. Okay, fifth is Newton's formula. Fifth is common roots. Okay, and last is definitions of identities, and some problem related to JEE. Okay, JEE mains. Okay, so actually in my previous class I have discussed relations between roots and its coefficient, okay, nature of the roots and transformations of the equations. We have complete nature of the roots and Newton's formula, okay, and some more important topics we can't complete. So next topic I will discuss common roots. Okay, so first of all we will discuss what is just I will remind something in quadratic equations. Just wait a minute. Okay, so first of all, what is quadratic equation? What is the standard form of quadratic equation? Standard form of quadratic equations: ax square plus b of x plus c is equals to 0. And it is true for all x belongs to R. For it, this is a quadratic equation. It is obviously E is not equals to 0. Okay. Then now we try to solve this equation. Okay. So now then we'll get two roots or two zeros, because there are at most two zeros. Okay. By the fundamental theorems of algebra says that what is the theory? So theorem says that and equations of n degree has at most n roots. Okay, that means if we consider this is the quadratic equation and it is the degree of 2, that means it has only two roots. This is, let's say, this is alpha and beta. Okay, so what is the proof here? That means we get only just two roots. So that means mathematically or mathematically always wants to prove. So how to prove? There are just two roots, alpha and beta. Okay, so just a minute, I'll obviously discuss the proof, because without proof mathematics incomplete in my thing or my view. Okay, so that means obviously when alpha is the root of that equation, that means alpha satisfies that equation and obviously beta satisfies that equation. So that means E of alpha square plus B of alpha plus C is equals to 0, and A of beta square plus B of beta plus C is equals to 0. So this is the roots of alpha beta, and let's if possible let there are if possible let's So my topic is, this is the by the fundamental theorem of algebra, we will get just two roots, alpha and beta. So we will let there is another roots gamma, okay, gamma which is not equals to alpha and gamma is not equals to of beta. This is the my assumption, okay. So gamma is another roots which is not equals to alpha and gamma is another roots which is not equals to beta, and gamma is the roots of this equation. So that's why this equation is satisfied, okay. A of gamma square plus b of gamma plus c is equals to 0. So now we will prove that gamma is coincide with alpha and gamma is coincide of beta. That means there are two roots, alpha and beta. So now we prove. How to prove? Let's see. So this equations, now we subtract. This is number 1, okay, this is number 2 and this is number 3. So we will subtract from 1 to 2. This is minus, this is cancel out, and this is a into alpha square minus beta square plus b of alpha minus beta is equals to 0, okay. So this is equals to a into alpha minus beta into alpha plus beta plus b of alpha is equals to 0. So this is the similar part, alpha minus beta. There is another similar part, same similar part, alpha minus beta. That means we will take common alpha minus beta, okay. This is a into alpha plus beta plus b is equals to 0. So so that means alpha beta is not similar. That means this is not equals to 0. That means this is a into alpha plus beta plus b is equals to 0, okay. So last of that calculation we have got that b into alpha plus beta into b, okay. So so that means so this is number 4. Another, this is the alpha into alpha a into alpha square plus b of alpha plus c is equals to 0. This is number 1 and this is number 3. If you subtract to similar pattern 1 2 3, okay, 1 2 3, that means this is a this is gamma square plus b of gamma plus c is equals to 0. That means minus, this is cancel out. Another, we will get a of gamma plus beta plus b is equals to 0. This is number 4. This is similar. We will get by the similar pattern. So a into gamma plus beta plus b is equals to 0. So now we subtract 3 from, this is number 5, 4 from 5. Then we get, this is minus and this is minus. This is cancel out. So this is a into alpha plus beta gamma minus beta, okay, and this is equals to 0, okay. So that means, so this is a into, so this is beta cancel out, alpha minus gamma is equals to 0. And obviously we have known that a is not equals to 0 because this is quadratic equation. Obviously at first we will write here alpha a is not equals to 0. That means so obviously this term is equals to alpha minus beta, alpha minus gamma is equals to 0. So that means alpha is equals to gamma, okay. And similar pattern we will get beta is equals to gamma. So that means in by this proof we will get there are two roots, alpha and beta. At most there will get just at most two roots. Otherwise we can't find any other roots with alpha and beta. Okay, this is the proof. That means in quadratic equation, this is degree of that equation is 2. That means we will get just two roots, alpha and beta, which is equal, unequal, distinct, maybe anything. So next topic is roots, nature of the roots. Okay, this because nature of the roots, because very important topic for JEE mains. Okay, some questions are came from this subtopic. I will discuss some problem, nature of roots. Okay, so this is nature of roots. Okay, so nature of roots. So actually, so this is ax square plus b of x plus c is equals to 0. Okay, so this is the quadratic equation, and obviously a is not equals to 0, and for all x belongs to R. This is the domain of that equation. Okay, it is satisfied for all x. So by the Sridhar Acharya formula or theorems, we have got x equals to minus b plus root over of b square minus 4ac by 2 into a. This is the solutions of that equation, quadratic equation. So main part is nature of the roots. That means nature of the roots are totally dependent on that part. So then on this term b square minus 4ac, because this is the root over of b square minus 4ac. So this term is called discrimination. It is totally denoted by capital D, which is b square minus 4ac. Okay, so this is the main part. Okay, so one by one I will discuss all the case. Okay, first case if d is greater than 0, then what happens? If d is equals to 0, that means x is equals to minus b plus root over of b square minus 4ac by 2a. This is the solutions of roots. Okay, so what is the nature of the roots? Totally dependent root over of b square minus 4ac, and this part is called discrimination. So discriminations, so if d is equals to 0, d is greater than 0, that means this is we will get here, that means real, the roots are the roots are real and distinct. Okay, distinct. Okay, and next case is if d is equals to 0, so what happens? So if d is equals to 0, that means this term is 0. That means we will get real roots are, what is this? This roots are equal and real. Okay, actually real and equal. Okay, and next is if d is less than 0. So what happens? So this means root over of b square minus 4ac. That means in the parts root over of b square minus 4ac is less than 0. That means this is imaginary number. Then with the roots are imaginary. Okay, roots are imaginary. Okay, and fourth is the coefficients of this is ax square plus b of x plus c is equals to 0. This is the quadratic equation. All the coefficient a, b, c, okay, a, b, c belongs to rational number. That means a, b, c are all rational number, and d is perfect square. Then what happens? Then we will get, okay, then roots are rational number. Okay, so this is the main important topic for JEE. And next is so if a is equals to 1 and b and c belongs to integers. Okay, so what is this? A is equals to 1 and a, b, c belongs to integers. That means b and c are integers number. Then what happens? So condition is says that, okay, then the roots are integers. Okay, integers. So actually this 2 point is very important for JEE mains and advanced. Some questions are came in G. I will discuss. Then you have understand the more main important points to this number 4 and 5. Okay. So next is so just I will write the questions. Okay. So okay, just restart the camera. So these questions, so I write the questions. Okay, so this is A, B, C belongs to rational number. That means A, B, C are rational number. Okay, so my first question, first condition is A, B, C are rational number. Then what is this? Okay, wait. So then the roots of the equations. Okay, that means this is given equation, and you have to find the roots are rational, real, irrational, or equal. So how do we solve this type of question? And this question came in JEE mains. Okay, I forget the exact the year. So so that is not important, but important is how to solve or how to approach these questions. Okay, so let's start. Okay, so at first so what is this? A, B, C are rational number. Okay, A, B, C are rational number. So next is, what is this? So A, B, C are rational number for rational roots. So for rational roots, so x is equals to for rational roots, so d is equals to d is perfect square. Okay, and A, B, C all, okay, all are rational number for for that equations ax square plus bx plus c is equals to 0. This is a quadratic equation. That means coefficients of x square and coefficients of x and this constant term all are rational number. But here is different. Coefficients of x square is b plus c minus 2a, x coefficients of x is c plus a minus 2b, and the constant term a plus b minus ca. But we have known in the property of rational number, additions or subtractions, additions of two rational number and subtractions always are rational number. That means this is rational number, this is also rational number, this is also rational number. That means coefficients all are rational number. But then we have to check the D, that means discriminations is perfect square. So what is the discriminations? Discriminations is root over of, this is c plus a minus 2b whole square minus 4 into b plus c into 2a, okay, into a plus b minus 2c. Okay, so actually what is this? So this is actually alpha and this is actually beta. If you let's say this term is b plus c minus 2 is alpha, this is alpha plus this is beta. If you write alpha plus beta, so what happened? So that is equals to, so b plus c minus 2a plus a plus b minus 2c. Okay, so this is so actually, so this is 2b, okay, and this is minus a minus b. So that means minus common a minus 1. So this is a plus b minus 2b, and this is actually, so this is alpha plus beta whole square. So that means this is actually so alpha plus beta whole square into 4 of alpha beta, and that is, we can write alpha minus beta whole square, and this is perfect square. That means all our coefficients alpha plus b plus c, this is all our coefficients, okay, all our coefficients are rational number, and these coefficients, okay, this is distributions of that equations are perfect square. That means so all roots of that equations are rational number. That means we will get, if we solve that equations, then we get all the roots are a rational number. Okay, this is the appropriate long method. You will solve these questions by this method, but there are very important trick method. Obviously, I will discuss here. Okay, just a minute. So if you put that equations x is equals to 1, then what happens? So that means b plus c minus 2a, and this is c plus a minus 2b plus a plus b minus 2c. Okay, 2c. So what happens? So that means so this is 2b, and this is minus 2b, and this is c, and this is so what is c? This is 2c plus 2c minus 2c plus 2a minus 2a. So that is equals to 0. That means when we put x equals to 1, okay, x equals to 1, that equation, then we get all the coefficients are 0. That means x equals to 1 satisfies that equation. That means we have got a equation now on roots x equals to 1, and 1 is rational number. Okay, so another roots, how can determine this? So just wait, just a minute. So this is a x square plus b of x plus c is equals to 0. Then it's alpha is another roots, and this is beta is another roots. Alpha is a roots, and alpha and beta is this roots of that equation. And relations between alpha and beta, we have got, okay, this is minus b by a, and alpha into beta is equals to c by a, and obviously a is not equals to 0. Okay, so we have got x equals to 1 is the root of that equation. So another roots, so this is, let's say this roots is beta. Okay, so that means so what happened? Just a minute, I will discuss the very important trick for that equations. Okay, you don't try to that previous method. Okay, so that means 1 is roots, and this is beta is the another roots, and the product of that roots is, that means this is the a plus b minus 2c by this is b plus c minus 2a. Obviously this is not equals to 0 because this is quadratic equations, that is not equals to 0. And what is this? This is divisions of two rational number. So divisions of two rational number, obviously rational number. That means beta is also beta is a rational number. Okay, so beta is also a rational number. Okay, so that means alpha, so 1 and beta are rational number. Okay, so this is the main this is the tricky method. So now I will take another problem for here. I will discuss just a minute. Because I stop the camera. Next question is let's start. Understand the problem. Let's understand the problem. Consider the equation x square plus 2x minus n. So what is this question is equations is x square plus 2x minus n, and what is the n? N is where n is belongs to natural number. That means n is natural number, and n belongs to 5 to 100. The limitations of n is, you have to take, you should take the values of n is 5 to 100. Okay, this is the most important conditions for these questions. And this question says that total number of difference values of n. Total number of difference values of n, so that the given equations has integral roots. Okay, so you have to determine total number of values of n. That means we will get all the roots are integral roots. So it is totally dependent on values of n. Okay, so integral roots, that means what is the conditions? Okay, conditions for okay, just I will write the conditions for integral roots. Okay, so conditions is the equations x square plus bx plus c is equals to 0, where a is equals to 1 and b and c belongs to integers. But questions is obviously here limitations of that questions is n is natural number, and natural number is also be an integers. So that means and 2, and for these equations x square plus 2x minus n, okay, this is 0, and d is perfect square. Okay, so this is the most important conditions. Okay, so a equals to 1 and bc belongs to integers, and d is obviously a perfect square, otherwise we can't determine these equations, okay, has an integral roots. Okay, this is the limitations of this questions. Okay, conditions. So here a is equals to 1 and b is equals to 2 and c is equals to minus n, and all are integers. Okay, n is natural number and minus n is negative of that numbers, that means negative, this is number is integers, so all are integers. So now we want to determine what is the d. So this is d root over of b square minus 4ac. Okay, so this is root over of b, that means what is the b? B is 4. Okay, and this is 4 into minus n. Okay, and this is into 1. Okay, so that means this is 4 into 4n. Okay, then this is 2 1 plus n, and what is this? N belongs to 5 to 100. Okay, so this is the conditions. Then you will determine. Okay, this is we and obviously this is a is each a, this is a perfect, this is a perfect square. Okay, so if we put n is equals to 7, so what happen? Sorry, not n equals to 8. Okay, so that means so this is 2 into 1 plus 8, that means 2 into this is 9 root 9, and this is 2 into 3, and this is 6. This is the integers roots. Okay, so if we put n equals to 8, n equals to 15. Okay, so what is the choice of n? So actually we have write 15. Okay, 24, and this is 35. Okay, and this is 48, and this is 63. Okay, this is 80. Okay, and this is 99. Okay, this is the choice of n. 1 2 3 4 5 6 7 8. So what is the choice of n? Actually there are choice of n is 8. Okay, so my answer is 8. Then you will get, if you put the values of n, then you will get by this term you will get all roots are integers root. So my answer is 8. Okay, hope you understand this. So next topic is